Today we will start 4.9 modeling with polynomial functions. So we have to find our functions or describe something very like case. The first is write the cubic function. Cubic function means the maximum power should be x power 3. The maximum power will be 3. Whose graph is shown? Graph is given. So if you look at the graph is cutting the x-axis at a 3 point, -4, 1 and 3. These are x-intercept. X-intercept means these are the three solutions. So I can write in a factored form. Fx is equals to x plus 4, x minus 1, x minus 3. There may be a constant term outside, because we don't know. These are just three factors, but there may be a constant term, constant multiply. And that can be done or calculated using any coordinate which is passing through the graph. Here we are provided with 0, -6. So substitute x as a 0 and the function value is -6. So I write a 0 plus 4, 0 minus 1 minus 3. So -6 equals to a, 4 into -1 and minus 4 3s are 12. So you will get 12 times a is -6. Then a is -1/2. A is -1/2. As you have a is -1/2, substitute in this. So y equals to, or you can say function fx is equals to -1/2 x plus 4 x minus 1 times x minus 3. This is the cubic function of the given graph. Okay, let's see the next one. Next we have properties of finite difference. Finite difference means when we calculate the difference and it comes out finite, and that's known as a finite difference. When we have a x values and x values are equally spaced. When x values are equally spaced, x values are equally spaced, the difference of consecutive y value, the difference of consecutive y values is finite difference. Finite difference. Okay. Let's see a question. Write a function using finite difference. First I have to check this is a linear equation. It will form a linear function, quadratic function or cubic. So we are using finite difference. Find the difference. 4 minus 1, 3. You can use only if your x values are equally spaced. Yes, x values are equally spaced here. Now check the difference of y values. 4 minus 1, it's 3. 4, 10 minus 4, 6. It's 10, 15. And this will be 1 here. If I calculate this, it's 1 here to 21. And this will be, we get 28. Now it's not same. As it is not same, again find difference. 6 minus 3, 3. And this is 4. This is 5, 6, 7. It's again not same. Again find difference. 1, 1, 1 and 1. Now the difference is same. Which difference comes same? Third difference. This is the first difference. This is the second difference. And this is the third difference. We got the third difference is same. As the third difference is same, So polynomial is a cubic. It is a cubic polynomial. And they also says use technology to find the polynomial function. You just have to substitute these values in a calculator and calculate the regression cubic equation. Make sure you calculate for cubic. If you calculate, you will get a function. You will get a function fx is equals to 1 by 6x cubed plus 1 by 2x square plus 1 by 3x. You will get this is the equation which is approximately same and it satisfies the given value. Okay, right. Next one. Next we have this question. The table shows the total US biomass energy consumption Y in the year T, where T equals to 1 corresponds to 2001. Find a polynomial model for the data. Use the model to estimate the total US biomass energy in 2030. So up to 12 years it's a given and for 2013 we have to calculate. Okay, so here we have to use graphing calculator. In the graphing calculator we will get a graph of, here I open the Dasmos cubic regression model. So on the left side I will substitute the value. When x1 is 1, y value is 2622. And then for 2 the value is 2701, then 2807, 3010, then 3117, 3267, 3493, 3866, 3951, and then we have a value for the 10. It's a 4286, 4421, 4316. Okay, so we get like this. We can zoom out how it looks like. You can check it where the graph it lies. Here are points. You can zoom in, zoom out accordingly. Okay, so these are the points and the line is just a tracing line. All the points will not pass through the points. All the points will not pass through the line. We are taking an approximate cubic line, a cubic function that satisfies this. Okay, alright. So let's see what is the equation. This is the cubic equation in which the a value, a coefficient is minus 2.545, something like this. Let's take this one. I will write this thing here. So I got this. Okay, as I got these as a values for the coefficients also, we are able to find the cubic equation. The cubic equation is y is approximately negative 2.545 x cubed. P value is 51.953 x square. And next term will be C. C is negative 118.114 because I'm round up to 3 decimals. And the constant last term is 2732.141. Okay, this is how we use the regression models here to calculate the cubic equation for this given data. Using this, I can calculate what is the value for here they ask for the 13, right? You can substitute 13 here. If you substitute x equals to 13, your y value will be approximately 4385. This is the answer. So we are done with the chapter 4. 4.9 is completed. I hope you understand. In the next video, we will do the review of chapter. Okay, thanks for watching.